Hello everyone, and thank you for joining us today. We're excited to bring you this overview webinar on ETAP 20.5, a continuous intelligence digital twin solution to plan, design, automate, operate, and optimize electrical power systems. ETAP 20.5 offers an impressive new set of integrated power analysis modules, electrical safety capabilities, digital transformation solutions, advanced renewable energy modeling, leading-edge CoSimulation technology, and model-driven real-time network management systems. As with all other ETAP releases, this release includes new solutions and features, plus hundreds of enhancements and time-saving improvements. So let's dive into ETAP 20.5, starting with the ETAP Digital Twin that unifies design, operation, and automation. With 20.5, you can confidently design your electrical system, perform system analysis and planning studies, visualize the results of your simulation through our smart visualization and intelligence, apply rule-based design, as well as the result analyzers to speed up your analysis and delivery timeframes. You can then take the ETAP Digital Twin, connect it with operational data to essentially operate your electrical system and achieve capabilities such as model-driven monitoring, operational awareness, predictive simulation, or in other words, validate before operate, and other real-time analytics such as forensic analysis, root cause and effect analysis, load forecasting, and many more. You can further augment the digital twin model with intelligent controllers to automate your electrical system and achieve situational intelligence, advanced optimization, proactive control and actions such as intelligent load shedding, as well as have intelligent control, closed loop control of your electrical system through power plant controllers and microgrid controllers. So let's take a look at some of the new products and solutions we've added to ETAP 20.5. We've added a set of capabilities to ensure safety and to maintain compliance with existing standards. We have improved design and analysis flexibility through various data imports, result visualization, and interoperability with third-party softwares. We've also expanded the portfolio for renewable energy integration and grid compliance in terms of solar, transformer inrush, as well as inverters. You will find enhanced design flexibility and high-fidelity simulation capabilities in ETAP 20.5 when it comes to flexible charting, scripting and automation, as well as electromagnetic transients. Simulation and analysis has become more flexible when it comes to railway traction systems, cable sizing, as well as user-defined dynamic models. We have improved our intelligent schematic builders and visualization, such as underground thermal raceway, the one-line diagram, and of course the ETAP interface itself. We've expanded our cloud and mobile offerings by providing enhancements to NetPM for project collaboration, data exchange, as well as the ETAP app, which is intended for tablets. And we've also expanded on our automation offering, which is the model-driven design and control software and hardware solution for microgrid control and energy management system, as well as renewable farm power plant control, or EPPC. On the operations side, we've expanded the Centralized Relay Asset Management System, or eProtect, a more sophisticated operator training simulator, as well as Advanced Fault Analysis System, or AFAS. So let's go ahead and take a look at some of these items one by one and through ETAP as well. Arc Flash Energy has been expanded to include compliance with NFPA 70E 2021. So that includes the AC and DC capacitor energy hazard assessment, as well as improvements to the German arc flash calculator based on BGI 5188. We've also improved the custom label capabilities by adding metric templates to the standard ETAP product. NFPA 70E 2021 has provided very valuable information for electrical workers on how to establish a safe capacitor discharge voltage and has provided guidelines for the risk assessment of capacitors to assess the arc flash hazards. So this latest revision of NFPA 70E now includes guidance for labeling the capacitors in facilities, and it recommends to label capacitors operating at or greater than 100 volts with a stored energy greater than or equal to 10 joules. ETAP 20.5 provides a full set of tools for the electrical safety community to comply with these new regulations that include a brand new capacitor stored energy calculator that gives you the capability to calculate the amount of discharge energy as well as the arc energy based on the discharge time for different capacitors in your electrical system. It also includes the thermal, shock and blast, as well as discharge and boundary plots, and the ability to generate a custom label out of the capacitor calculator. You can also calculate the capacitor thermal energy with the network calculation within ETAP arc flash analysis. In this sample, an arc fault is placed on switchgear A, and when the arc flash event takes place, the energy of the capacitor is expected to dissipate quickly due to the relatively small resistance of the arc. As we examine the fault location, we can identify that there are a total of 3 contributions from the source, the load, as well as the capacitor bank. Keep in mind that for most cases, the capacitor thermal energy is relatively small compared to the energy that comes from the actual voltage sources. However, there are exceptions such as large cap banks which can store a significant amount of energy. ETAP can also evaluate how much incident energy is released when the system has multiple capacitor banks, and that's also illustrated in this system here by essentially compounding the energy from each of these capacitor banks to the faulted point. ETAP 20.5 therefore has been enhanced to allow you to calculate the capacitor stored energy contribution based on the new guidance provided in NFPA 70E 2021. Feel free to register on the ETAP website or watch our YouTube channel for a webinar associated directly with this particular feature and capability. ETAP 20.5 includes an expansion to the arc flash calculator based on the German standard DGUV 203-078, which was previously known as BGI GUV 5188. This is the guideline for the selection of personal protective equipment when exposed to the thermal effects of an electrical fault. And this standard is mainly used for LV equipment and allows for PPE selection based on GUV 203-078 method as well as Shaw-Halinka method. This is an independent tool that is quite user-friendly that allows you to easily put in the voltage, electrode gaps, working distances, as well as the short circuit current to determine what the incident energy levels are going to be. And in ETAP 20.5, we've added user-defined incident energy reflectivity factors such as KP or normalized power and KT, which is transmission factor. You can essentially use these to determine the spatial propagation of the energy release as well as the geometric relationship. You can also get German arc flash labels directly from this calculator. Additional capabilities in ETAP arc flash include updates to the auto evaluation interface, a new enclosure editor filter that allows you to filter the components directly from the one-line diagram, and all the arc flash calculators now include batch Excel import as well as the ability to print custom labels. Another new capability that has been added to ETAP 20.5 is current transformer saturation, which is used to evaluate the current transformer size as well as the turns ratio. And this is done based on IEEE C37.110 as well as IEC 60044-1 in order to determine the CT saturation, and based on the probability of CT saturation, we can evaluate the CT size. From this tool, you can also get the ideal, actual, RMS, and the magnitude for your current plots. You can also use it to import waveforms in order to see the worst case fault inception angle and plot three-phase currents, that is phase A, B, and C. The current sizing and saturation calculator is available from the CT or the current transformer within ETAP by going to the rating page and accessing the CT sizing button. As soon as the CT sizing editor is launched, you can just plug in the inputs and visualize the results directly onto the calculator chart. The program allows you to plot the ideal, which is shown in blue, actual, which is shown in black, along with the respective RMS values. You can adjust the relay burden and recompute and watch how the CT saturation is affected as you add more relay burden without changing the CT size. This exciting new tool is available to all our users who are currently utilizing ETAP Star. Plot view was available in ETAP 20 as part of our standard offering in the base module, and it's an advanced framework for charting and graphing. We have expanded this framework to include embedded live plots on the one-line diagram for new modules, as well as a plot view for device editors. Live plots are now available for renewable and railway systems, as well as the device editors, such as the transformer harmonics, as well as the photovoltaic library to represent the PV and IV curve. We can take a look at the plot view for time domain load flow very quickly. You can easily apply a plot view to the view by selecting the plot parameter from the right click for any given component. You can then go ahead and run your simulation as usual and watch as the plot view updates the results as the calculation progresses. But the true value of the plot view also comes into the picture when you quickly switch over to a different condition or a different configuration or a different scenario altogether and evaluate what is the before and after effect of switching between different what-if cases across different devices. You can also see the plot view directly on to the devices, such as the harmonics page. And the plot view allows you to quickly zoom in and see the values and track the values directly onto the charts within the editors. You can also go ahead and open up a PV panel and track the same information inside the PV panel for the selected curve based on its irradiance levels. So these plot views are essentially now available for the harmonics page as well as PV array, and will be expanded throughout the rest of the program in the next upcoming release. Another exciting new capability that we've added in ETAP 20.5 is the plot analyzer, which is an advanced graphical plot comparison tool. This tool is available to you based on the modules you've already purchased or have licensed within ETAP. It gives you an efficient method of doing power system analysis by comparing graphical results from multiple studies, as compared to the result analyzers that allow you to do the same comparison except that they are in a tabular fashion. This plot analyzer comparison works based on a high-speed Python framework. It's available for all modules with plot-based reports and features numerous enhancements and capabilities such as automatic sizing and subplot arrangement, tooltips and crosshairs for tracking the values, ability to copy the data to clipboard and export these values to Excel, the ability to configure the plots and settings by going into the Python script and adjusting what you would like to see, automatic display of event and alert information, as well as the ability to add some certain custom scripts using Python and generating your own plots under certain modules. So let's go ahead and see our plot analyzer in action. In order to do so, we can take any module such as time domain load flow and go ahead and run the calculations within ETAP. Note that in order to use the plot analyzer, you don't necessarily have to utilize more than one plot output report. The plot analyzer allows you to visualize a single output report as well as compare more than one plot file together. You can simply open up the plot selection, select the components you want to visualize from a single report, and go ahead and plot them. The program will go ahead and give you the plot view directly in a browser, which you can actually email to another engineer or colleague, because this plot actually includes all the data that goes behind generating the plot. You can also pan left and right and see different areas of the plot you may be interested in. And you can also switch between different themes wherever possible, between dark mode as well as light mode, especially when it comes to visualization versus print. You can also plot more than one variable on the same chart and combine multiple plot types within the same plot. And once you have plotted different variables, you can not only see the values, but you can individually turn certain channels or trends that you have plotted on or off after the chart has already been created. So again, this saves time when you are fine-tuning your deliverables after the chart has already been created. But the true power of the plot analyzer comes into the picture when you are running more than one scenario inside the program and generating different results. In this case, we can see different results being displayed on the plot view, which is our live view that's directly embedded onto the one-line diagram. And we're essentially looking at the generator relative angles when we change our fault clearing times to determine the critical fault clearing time for this system. And if we go ahead and plot one of the generators with respect to different critical fault clearing times, we can see the relative power angle for time equals 0.3 seconds, 0.2 seconds, and then finally the blue line, which is at 0.116 seconds. We can also see the events directly on the chart, and these events are essentially coming from the study case in this particular system, or it may be coming directly from a relay. We also include the scenario information directly on the chart, so it makes it easier for you to print. You can also go to the buses, and what you will realize is when you plot voltage and angle for these different scenarios together, we not only give you the voltage and the voltage angle plot, but we give you a new type of plot, which is a 3D plot, which is voltage, angle, and time. So you can therefore see the voltage and angle as a polar chart, or you can see voltage and angle as a 3D chart, which is particularly useful, especially if you're trying to see the voltage decay as a function of time for rotating machines. You can also select different tools to zoom in and zoom out, and of course use the tooltip to see granular detail in any of these charts. Let's take one more example for our transient stability program, where we can run different scenarios, such as system islanding, where we're actually opening a breaker to isolate an induction machine in the system. We are also running another scenario where we're actually placing a fault in our network. Now, when we go ahead and look at our buses, once again, voltage and angle, when we are coasting our induction machine, we can see the voltage and angle decaying as a function of time, as that angle and voltage is essentially approaching zero and spinning and approaching zero. And then we can also go ahead and look at our generator plot in terms of a coasting event as well as a transient fault event. And we can see this through the relative angle. We can combine the plot as usual from two different types of studies and see the impact of coasting as well as the fault on the generator. So here we can see the coasting case in blue and the transient fault case in orange. And once again, we can see the events in the system that include the study case events as well as the ETAP created events from the relays. The events are distinguished by a circle as well as a cross arrow. You can also see the machine Z, or the machine impedance, as a 3D chart. When it comes to motor starting, you can essentially have many cases or many applications of the plot analyzer. One of them is essentially quickly looking at a particular motor starting event when it comes to direct across the line versus auto transformer versus capacitor bus versus stator resistor, and take all these different methods and combine them together to quickly identify and determine what the inrush current is under every single condition, and where are the voltage violations in the system. And here the voltage violations are shown with a halo or a shaded color around the chart, and that gives you an idea for what duration of time there are under voltage conditions in the system, especially the connected bus where the motor is connected. And then again, it helps you quickly identify and determine the type of starter you may want to use in the system. Another fantastic capability that we've added in ETAP 20.5 is AutoCAD import. So this AutoCAD import is a huge benefit for those of you who are trying to go through your digital transformation process, digitizing your data, which is in CAD format. You want to bring it into ETAP so that you can maintain and design the digital twin, and then in time integrate that with your three-dimensional modeling tool. So this is the necessary first step towards digital transformation, and it's essentially used to synchronize the engineering, construction, and maintenance teams together. We can automatically generate a one-line diagram once we read the AutoCAD file, and you can also use it to automatically generate the substation ground grids. So the AutoCAD file that is being read by ETAP is then converted and including the connectivity into the ETAP model. So let's take a look real quick. If you take a very simple file like our standard example file in AutoCAD, you can go ahead, add a command dwg to ETAP in your AutoCAD program, go into ETAP into a brand new project, go to Data Exchange, select AutoCAD import. We automatically discover the AutoCAD license and the AutoCAD program that is already running on another computer. We can then go ahead and click on the mapping file, and the mapping file essentially helps us compare the AutoCAD elements with the ETAP mapped elements. So we've already done the hard work of pre-mapping a lot of these components over to ETAP, but in case any of these components are not mapped or correctly mapped, you can adjust the mapping for your system and then import the file directly into ETAP. And as you can see, the layout is quite clean, and this saves many man hours of rework, especially in a very large oil and gas refinery or large industrial system, even a large commercial building where you can spend a couple of hundred hours just simply rebuilding the model from scratch. We've also improved our element editors to include new fields and capabilities for cable sizing and transients, plot views for PV array and harmonics, capacitor editors for arc flash energy, and two-winding transformer for withstand protection of IEC two-winding transformers. The ETAP API is new. It's a RESTful API for interoperability, and it's a web services-based architecture for ETAP to interact with other applications through data messaging. So through this API, you can connect to ETAP from any device or any platform. We provide the necessary services over a REST API, and it's implemented also as a Python client in ETAP PY. You can use the ETAP API to essentially connect to ETAP, run scenarios, studies, get project data, etc. And it's essentially an ongoing activity within ETAP to expand this API, including the API that we are using for Python scripting. So we have obviously integrated ETAP and Python scripting in our previous release with the built-in Python IDE for running scripts. These scripts can be executed locally or remotely over computers so that you can run studies in parallel. And you can also benefit in ETAP 20.5 from an expanded Python API for running voltage stability and harmonic analysis. You can also test and try Python API with Swagger. Simply open up the Data Hub, click on the ETAP API, get this beautiful Swagger page that allows you to quickly look at the API commands. Select the command of your choice. Select the component variables that you would like to type in, or the command variables. So in this case, I would like to get transformer T2 impedance, and you can go ahead and just try it out. And once you try it out, the program will tell you what the value is, And that's all done without writing a single piece of Python code. You can also go ahead and try another one to set the element properties. So once again, we'll type in transformer and select our transformer T2. The field that we would like to change is the positive impedance, and you would like to change it to a value of 7.9. So as soon as you execute, you'll see on the diagram the value switch from 6.9 to 7.9. And with this, you can quickly try certain commands if you're not familiar with Python, or you can essentially start writing Python code yourself. So let's take a look at another example of automating ETAP with Python, such as sweeping the transformer impedance and generating a plot file. So we can again open up our Python IDE from the system toolbar, select our Python script, in this case, which we have already pre-made. This Python script essentially reads the transformer impedance and changes it in steps of 0.5, 5, 5.5, 6, 6.5, 7.5, 8, 8.5, and so on, and running a load flow computation at every 0.5 step. And then it reverts the value back to 7.9 after it's finished. And you can use the plot analyzer to see impedance versus voltage magnitude. And you can see, as expected, as the impedance is increasing, the voltage drop on the transformer is increasing, and you can use it to right size the transformer. Of course, you can combine this with short circuit and overlay a short circuit plot along with the change in transformer impedance, and again right size the transformer. With ETAP 20, we reached an important milestone by releasing ETAP EMT, or Electromagnetic Transient Program, that allows for electromagnetic engineering simulation in a familiar and user-friendly ETAP environment, which includes the ability to do insulation coordination, switching transients and surges, torsional stress, subsynchronous resonance, ferroresonance, lightning surges, and of course transient recovery voltages. ETAP EMT now includes a sparse matrix solution, modified augmented nodal analysis algorithm, multi-time step PNI, which allows multiple transmission lines to be linked together from different projects at different time steps, new master library models, numerous wiring drawing enhancements, and program automation through embedded Python scripting with the ability to record the Python scripts. Related to ETAP EMT is EMT CoSim. ETAP EMT, if you recall, allows you to simulate electromagnetics. EMT CoSim allows you to co-simulate electromagnetics and phasors. Therefore, it provides a bridge for hybrid simulation between ETAP Transient Stability and EMT programs. ETAP Transient Stability Program and EMT are combined to collectively solve large, complex, and multidisciplinary system models with high fidelity. So for example, you can take a power electronics simulation, including faults, protection right through, etc., apply it inside EMT domain, and solve the RMS domain as a shunt-connected device. EMT CoSim offers a hybrid simulator that consists of EMT and dynamic phasor-based simulation. ETAP EMT simulator is used to model the portion of the network where fast transient analysis is needed. The transient stability solver is used to simulate the rest of the network in phasor domain. ETAP has developed several integration methods and signal processing algorithms, which are basically converting waveform to phasor data to accurately map instantaneous EMT and dynamic phasor data in a fast, easy to use, feature-rich, and robust CoSimulation solver. This solver is now on version 2.0 with our ETAP 20.5 release, where you can watch your transient simulations in action with live charts, use multiple CoSim elements per bus and multiple CoSim buses, consider transformer phase shifts on the RMS network, and graphically chart data using Python-based reports or plots. We've also expanded ETAP transient stability to ensure accurate power system dynamics and transients. With ETAP 20, we saw the inclusion of transformer inrush, With 20.5, we've added transformer inrush with remnant or residual flux. We've added the ability to model a grid-following inverter, and we are allowing an interface with solar energy storage and wind turbine dynamics via vendor-supplied DLL. Transient stability has also been enhanced with the plot analyzer for graphical plot result comparison and evaluation, features 3D plots including voltage, angle, and time, and a brand new progress bar with elapsed time and remaining time that can be visualized. Harmonic analysis is typically used for identifying harmonic problems, designing filters, and reporting harmonic limit violations. And in 20.5, we have enhanced our harmonic analysis module to include the plot analyzer for graphical result comparison. We also now allow you to combine voltage and current distortion into a single plot for branches and buses. And we've also added G5 planning and compatibility harmonic limits rulebook as part of 20.5 rulebook release. A typical application of the plot analyzer for harmonics would be to easily compare a system without harmonic correction, inclusion of passive filters such as single tune filter, bandpass filter, bypass filter, and understanding the effectiveness of harmonic mitigation in your power system network as seen through a waveform as well as the spectrum. And the spectrum can essentially be overlaid on top of each other across different cases, and you can easily analyze the effectiveness of applying harmonic mitigation methods. Reliability analysis has also been enhanced to include the plot analyzer for graphical plot comparison. And one of the typical applications for this would be to perform sensitivity analysis across different conditions, across different single or double contingencies, and looking at the most sensitive components and the impact of the reliability of having an outage on these components. And based on different conditions, you can then quickly isolate which are your most critical components that require higher redundancy or reliability across many different what-if cases. ETAP star has also been enhanced to include a brand new tool that allows you to assess and resolve protection coordination data quality issues. This tool uses protected device functions and various logic assessment to quickly identify missing information, disabled functions, and many other logic checks. ETAP star view also includes a new ability to auto-fit the TCCs based on resolution and available display area, which you will find quite handy, especially when you're switching between your laptop and desktop frequently. The PD assessment tool essentially allows you to look at a tabular view of the devices, device types, manufacturer, model, assessment level, and the assessment details, so you can quickly identify and fix any particular problem in your system. So let's take a look at this tool with a quick example. In order to access the star PD assessment tool, simply click on the star mode. You will have the device assessment tool available to you if you have access to the ETAP star license. And you can go ahead and essentially run the assessment and see the results in a nice tabular fashion. You can add or remove columns to see more or less information related to the network being assessed. You can also select the table, export this data into Excel, or copy it to paste it into a Word document or an Excel spreadsheet. And you can simply check or uncheck these filters to navigate between different alert thresholds. And you can of course also go ahead and clear all the filters. So we'll go ahead and click on the alert view, look at circuit breaker 15, which is not selected from the library. You can simply click on CB15 once and the program will take you to that device, or you can double click on that device, open up the editor, and you can see that there is no trip unit specified here, in which case you can simply go ahead and switch to a device that actually has a trip unit. Click OK, and the program reassesses that device and takes it out of your assessment list. So similarly, you can go ahead and complete all the alert messages and then navigate over to the next level, which are the warning messages, and then finally the informative messages, and decide which of these messages need to be addressed and solved. So this device assessment tool really helps you figure out all the data quality problems. And you can also use it as a tool to essentially copy and paste the data and send it off for either data collection from the field or provide it to your engineers who are responsible for plugging the data into the model. We have enhanced motor starting to also include the plot analyzer for graphical plot comparison, as we saw earlier. We've enhanced the progress bar to include elapsed and remaining time. And we've also expanded the time slider to include the motor starting events, similar to transient stability. The cable systems in ETAP have been enhanced to ensure further compliance using the trusted calculations that you expect from ETAP. The cable model itself has been expanded to include new physical layers such as bedding and filler. We've expanded the cable transient load profile to handle additional points, taking you into the 24-hour profile. We've also added standard table based on overload protection or I2 calculation. And we've expanded the cable manager to include the correction factors and tables from various cable sizing programs. So this allows you to look at the correction factors and the corresponding tables without opening up every single cable editor. The underground cable ampacity analysis has also been improved significantly to include snap to grid and snap guides, very similar to what you would expect in Microsoft PowerPoint. We've also added plot analyzer for graphical plot result comparison, and the transient temperature calc now uses a complete 24-hour time profile. So let's take a look at the underground cable analysis, snap and snap guide in action. So as you move the conduits within the program automatically gives you the distance from the conduit to the nearest conduit. It also gives you the X and Y coordinates of the conduit that you're actually moving. And you can also turn on the center to center spacing as you move objects around, and use the snap guides to essentially place the heat sources or the conduits very precisely without actually opening up the editors and typing in any values. So it makes for a much faster data entry process. And you can also look at the center to center and edge to edge spacing. So if you look at a larger underground raceway system, you can turn on the center and edge spacing or center to center spacing and visualize it all at one time. You can also turn on edge to edge spacing, and then finally you can also turn on center and edge spacing. And the benefit of doing this is, of course, you can go to the print preview and visualize this information in a printable manner and make your deliverable more meaningful along with the dimensions. Another brand new capability that we've added in ETAP is solar PV parameter estimation. So this adds on to parameter estimation capabilities that we've had in ETAP for components such as induction machines. The process is very similar. We allowed the program to essentially estimate the PV and IV characteristic based on vendor nameplate data. The estimation is based on 1 or 2 diode model for the performance estimation, and we can also update the parameters into the solar library. So the user simply needs to put in the vendor nameplate data, and ETAP performs the model identification through a single or double diode model where we determine the required parameters such as series and shunt resistances based on certain diode ideality factors. The parameter identification is then performed, and then we assess the deviation from the vendor nameplate to the identified parameters or the curves. And then based on this information, we can update the PV and IV curves into our solar panel library. Time domain load flow has also been enhanced to include plot analyzer for graphical plot result comparison, live one-line diagram plots for graphical results, and an updated progress bar with elapsed time and remaining time. UDM scope plot view is also improved that allows you to plot UDM, transient stability, motor starting, and short circuit IEC plots from one tool. You can import CSV and SQLite database plots and analyze various plots such as relative angle swing, motor fail to start, over and under voltage and frequency, over and under damped waveform responses, and also have user-defined plot comparison instruction files and data visualization tools. So let's take a look at UDM scope plot view very quickly in action. You can load up a number of transient stability plot files. select the ones that you want to plot, and then go ahead and plot the selection, and then the program gives you a nice representation or plots of every single transient stability output plot. You can then go ahead and select the analysis tab and select the relative angle or any other type of analysis that you want to perform on the plot. Select the plot files themselves, and then go ahead and allow the program to plot based on a particular criteria. So you can essentially select, give me a rotor angle for these different types of studies that I've done that are exceeding 80 degrees. And then the program will essentially run through these plots, look at the values that are exceeding 80 degrees, and just give you the plots for those. So essentially helps you analyze the information such as EFD, rotor angle, and other parameters very quickly and efficiently. You can of course see the UDM scope plot view in more action in an upcoming webinar. In UDM, we've also added the ability to UDM or vendor black box models for PV, wind, energy storage, and generators. The vendor intellectual property data is protected via a dynamic link library using base classes for transient stability. So the user code or the vendor code is wrapped in a transient stability API, and a new DLL is created, which is a wrapper DLL. And then this DLL is linked to an ETAP component such as a PV or wind turbine or energy storage. And then you can simulate that component with the vendor specific code that is black boxed and wrapped into a protected DLL along with ETAP transient stability. So this capability has been enhanced in ETAP 20.5, and we've also added generic static VAR system or SVS based on Western Electric Coordinating Council dynamic models. eTraX, which is a solution for AC and DC railway system, has been enhanced as well to include live plots for the one-line diagram, improved current limiting under low voltage conditions, and we've also added new plots for StatComs and static VAR compensators. The plot analyzer is also available, allowing you to plot various timetables and the impact of various timetables onto a single chart. We've also added multi-axis 3D plots along with route and timetable plot and some custom Python plots at the same time. So you can essentially see a Mari diagram that allows you to see the station name versus time along with the timetable. You can of course overlay multiple plot types onto a single chart, compare the output of various timetables onto a single plot analyzer, and then look at a 3D chart such as voltage, day, and time to understand the impact of a daily, weekly, or any other type of duration timetable that you would like to chart. eTraX also includes an improved progress bar and status view for elapsed time and remaining time. We've added sequence of events along with DC rail current and voltage drop and distributed train load that allows us to essentially simulate the impact of very long freight trains moving through a system that has various bends and curves and so on and so forth. So after the eTraX analysis is run, you can see the time slider has been expanded. You can see the events show up here. And as usual, you can see the animation of the train, the color contouring that tells us over voltage as well as under voltage conditions that may happen in the system, especially in the case of an energy storage device. And you can also see the plot view directly onto the one-line diagram. DataX includes a brand new built-in conversion for NFS and NRED formats. NRED is used for load flow analysis, whereas NFS is used for short circuit analysis. And the import from these formats includes an automatic one-line diagram generation. We've also improved our SKM Power Tools import by adding a brand new capability that we'll cover shortly that provides a much improved one-line diagram layout and element mapping. And the conversion automatically creates a new component which we call a split bus, again, which we'll cover in a little bit. The DataX modules also include a built-in conversion for MillSoft windmill import that has been expanded and improved as well. It now supports incremental data file import, and we've eliminated Java support required for this tool. Network model management and project management is also enhanced to include automatic synchronization of the OLV with this new split bus component. The synchronization includes annotation and graphics, and you can also revert data using NetPM local change queue. NetPM, as you know, allows you to collaborate in parallel from anywhere. So an engineer in California or a planning engineer in India, a project manager in a different location, an electrical engineer in Texas, and a design engineer in UK can all collaborate together on the same ETAP model on the same platform using the NetPM platform. ETAP App 5.0 also interfaces with NetPM and provides the ability for doing mobile field data collection and synchronization, and it includes new updates such as element property filtering, text box style templates, a device search by the device type, and picture sorting capabilities. The engineering libraries that are verified and validated have been expanded significantly. We've added over 16,000 solar PV array models to ETAP using the new solar estimation tool. The circuit breaker and relay models, along with new protected device models, have been added as well. And we've updated our cable libraries again per cable regulation types. On the automation side, we've enhanced our microgrid controller offering to include a user-friendly controller designer, and also included ETAP in the loop situational intelligence along with parameterization of the microgrid controller. The operator training simulator now features software in the loop system operation along with dynamic and steady state response with the controller and relay action. So you can also use the OTS as a means to provide software in the loop testing and validation for various controllers such as the ETAP microgrid controller as well as the power plant controller. The traditional OTS, however, also gives you trainer to trainee environment with ad hoc and predefined scenarios, as well as the evaluation of the trainee performance. AFAS includes fault information retrieval using COMTRADE format and fault type identification. We use sophisticated phasor and frequency estimation to compute the fault impedance and do the location identification, which is then graphically visualized and reported onto the one-line diagram, GIS, or in an Excel-based report. The power plant controller is a model-driven power plant controller solution that includes new functions such as active, reactive power, and energy storage management. It can take advantage of ETAP in the loop situational intelligence. You can use the power plant controller for designing and operating your power plant for grid code compliance. And we've expanded the power plant controller to include new renewable energy SCADA and dashboards. eProtect has also been enhanced to include complete relay and asset management information. We've improved the data synchronization between the physical relay and ETAP star protection and coordination program and expanded on the automatic processing and relay setting file generation. eProtect allows you to connect the protection relays, your ETAP design and analysis workstation through a modern web client and a centralized asset management database. Through eProtect, you can bring in the as found settings into the database and send them to ETAP star for protection and coordination, adjust the protection and optimize the settings, send the optimized settings back to eProtect, record them, and send them back to the actual relay. You can also bring in the fault current waveform and send them to the protection program for analysis and assessment. And you can determine the fault location from the design and analysis workstations and send them back into your centralized database. The as operated sequence of operation can also be retrieved from the relay, and then you can compare the as found, as optimized, and as operated sequence of events and evaluate the performance of your protection devices. Please feel free to look at the eProtect webinar for more information on this particular solution. ETAP 20.5 also includes project tracking and a Gantt chart capability. It allows for quick and easy task and milestone creation. You can then task your project progress with an automatic Gantt chart update and quickly track the progress of your system studies, your scenarios, data collection activities through a Gantt chart that you can print and provide as a deliverable. And it provides a quick and easy means to use a project management tool without actually having MS Project. The ETAP application itself has been enhanced to include split bus for improved layout and organization. So it allows you to take a very long bus and split it graphically such that you can improve the one-line diagram layout without affecting your power system study calculations. So we can see the split bus in action here, where we can simply take one of our buses using auto build, add new pieces of equipment to that bus. And as that bus becomes quite long, the analysis results are hard to visualize in a single view. So you can simply right-click, split the bus at the location of your choice, grab the bus and move it to a new location that is easy and convenient for you to manage and visualize the load flow results. And this way you can essentially print your diagram without having to miss out on some of the finer details. And you can then also take the split bus and merge it back into your main bus by simply dragging and dropping the split connections and without affecting your actual calculation results. And this works on the one-line diagram across all modules. The data blocks have also been expanded to display metadata links such as pictures, manuals, etc. You can also display switching device configuration status, quickly search and use device properties, and apply display style individually or based on a theme. So let's take a look at the data block in a little bit more action. You can double click on a data block. You have an option to use a theme, which you can uncheck and apply custom color per entry of the data block. So in this case, the ID is bold and in blue, or you can apply theme-based coloring, in which case the ID and all the other device parameters are in red. You can then select a particular row, change the font style, the font size, as well as change the font color on an individual basis and apply it to your data block. You can also open up a data block for a particular component such as high voltage circuit breaker. Quickly search the parameter you're looking for, such as ID, by just typing it in, and the program auto completes the search. You can also now add configuration status, which allows you to include open and close status directly onto the data block itself. Change the font style as usual and the font size. And once you click OK, you can now see the configuration status per component. And as you right click and open and close the breaker, the data block status for that breaker changes dynamically. You can also go to the display option and of course turn off the data blocks that you don't want to see by device type. And once again, if you open up the data block editor, quickly search for hyperlink, you can now insert a hyperlink tag onto the data block. And once you define a hyperlink for a component, the hyperlink then appears directly onto the data block. So once again, you can drag and drop the hyperlink button, type in or browse for the file that you would like to link to, for example, an image file. Put in a description that is meaningful, such as nameplate for this transformer. Click on add. You can of course click on the link to test it. And once you click OK, you can see that you have a hyperlink onto your data block, which you can of course change the justification, select the style, and essentially change the font size as well as it makes sense. And you can then click on the nameplate as usual and get to the picture of the nameplate or the manual or a schematic or a specification of that particular equipment. So through data blocks, you can easily bring in the breaker status, you can change the style, and you can also bring in hyperlinks and visualize them directly onto the one-line diagram. Another capability that we've added to ETAP is graphical device selection by type. Simply press the Shift key and right-click on any device, and the program automatically selects all the devices of the same type, allowing you to make common or bulk actions such as changing the size, changing the font style, changing the thickness of the buses, and so on and so forth. So it's a very quick and effective way of changing all the devices of the same type without having to graphically select each and every one of them individually. We've also added the capability to toggle the service based on the device type. So you can simply go to the System Manager, select a component of your choice, right-click on the component group and toggle between service in and out. And you can see that the program automatically takes all the components of the same type and changes the service status. Another very neat application is Auto Rotate. What it allows you to do is, of course, build the one-line diagram as usual, but then as you move the components above or below the bus, the program automatically and intelligently rotates the components, making it much quicker to clean up and lay out the diagram. So this, of course, works with sources and loads, but also works with relays. So you can simply move the relay back and forth and see the CT change its mirror position automatically based on where the relay is located. Another nice feature that we've added in ETAP 20.5 is an automatic service pack updater. So service packs are typically used when we are essentially adding new capability into the program or expanding on some of the compatibility issues as Windows operating system and Microsoft Office continue to evolve. And these patches are provided to you now through an automatic updater service that you can just simply click on Help, check for update, and the program will check for updates and let you know if there's a new update available for you to download. So this is applicable only for the service packs. The major releases are offered through our help desk as usual. And finally, you will find that ETAP 20.5 overall has a very small memory footprint. Our R&D group has worked extensively to reduce the memory footprint by up to 80% on very large projects. You'll find it more responsive throughout, including better high-resolution display support throughout the ETAP program, which is a continuous activity. Library and project conversions have been improved in terms of its speed, and we've added new license manager features and more compatible installation across different types of operating systems and languages. The system components themselves have been updated, such as a Mongo database, which is now using version 4.2.x. Microsoft SQL Server Compact is now at 4.0. SQL Server is 2012 Service Pack 4. We have added compatibility for Microsoft Server 2019, and the ETAP Python API is now compatible with Python 3.8.4. In summary, ETAP 20.5 is a massive step forward in the design, automation, and operation of power systems. It is based solely on customer feedback, industry demands, and the future of power system design and management. We are really excited in offering you these groundbreaking features and capabilities, and we are looking forward to having you try them out. ETAP 20.5 will be available for download from ETAP Help Desk. If you are not an ETAP user and you would like to purchase ETAP or reinstate your software maintenance agreement, feel free to contact us, sales@etap.com, for more information and pricing, or request an online quote at etap.com, request pricing. Thank you once again for attending this webinar and hope you have a fantastic day. Thank you.